Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. That's right, it's another episode of Data Skeptic Machine Intelligence. Today specifically, as the title suggests, we're going to talk about the use of large language models in our everyday lives. But what does that even mean? Anybody can go to Chat GPT or Bard or whatever system, ask it for advice. Although the RLHF, the reinforcement learning with human feedback, I think they've gone a little bit aggressive with it. Ask it a deeply personal question. It caveats it with all these hesitations. Should I do X with my life? Almost certainly, it'll say something like, that's a big decision. Think about it very carefully. Here's a list of things to think about. Maybe that's useful, but that's the most basic, at face value way of using a language model. We're in the early days, so let's speculate about what's to come, and maybe how you, the listener, can be the one to bring it to what's to come. I certainly use large language models, and you can too. And I don't mean just by talking to them, although that's useful too. So today let's focus on the role of a data scientist, or as that term seems to decline, maybe the role of an ML ops engineer, or just a general engineer, or just a human being who wants to bring these technologies into the process they're working on. So at the most fundamental level, let's take on a harsh reality. The vast majority of you, maybe even myself included, we will never, ever train our own large language model. It's too expensive, and there's really no point. I could quote some statistics, but all those are going to change. The hardware is going to get faster, the training algorithms are going to become more efficient, and the cost of the commodity hardware that's used, massively parallel, massively in the cloud, all that's going to change, as will what a dollar means as we go through cycles of inflation. But needless to say, it is today and will likely remain absolutely inaccessible to the average person to train their own large language model. Let's talk about the lowest level I think the average person might go. Well, the average person's just going to talk to a large language model. That's not right. But the developer types who probably listen to Data Skeptic, where do you start? Well, the first question to ask is, are you attached to one of the cloud platforms? Google Cloud Platform has Vertex API that uses the Palm 2 model, or at least as I record this. Who knows? On Azure, they have a nice integration with the OpenAI API. Although you can also do that directly. I have an OpenAI API key that I use. Although what I'm using more and more, and this is not an endorsement, just a matter of practicality, because I have a lot of clients on Amazon Web Services. Over there on the other cloud option, you have Amazon Bedrock, a not intuitive name that offers a wide range of different large language models, kind of like Vertex and kind of like what OpenAI has. Get yourself programmatic access to one of these APIs if you're a programmer type. And even if you're not, it is basically a one-liner. Well, arguably like a 5-liner, but you know what I mean. The programming necessary, that you can pretty much copy and paste from a million websites that share the details. You import some library, Botto 3 or otherwise. You initialize some helper object that you're going to use to connect to the API, some client object. And then you send a very simple REST API request. Here is my textual response. I would like a certain model to process it. Maybe DaVinci, maybe something else. And back comes a JSON response, a well-structured data object that contains the contents of the large language model's reply. Your computer did no compute. It did no inference. It did no work. It didn't heat up in that activity. This is truly software as a service, or AI as a service, or models as a service. I don't know what it's going to be called. When using these tools, you're relying on those third parties, those clouds or other API services. I'm sure there are more today and going to be more in the future. They will give you a large language model as a service. You pay pennies on the dollar for each request, and you do with it what you will. The obvious thing is to make a chatbot. Although in any practical situation, how exactly are you going to keep that chatbot on the rails if people want to mess with it? Or even quite frankly, there's a weird way people could steal CPU from you. You set up a chatbot, you give it some prompt like, respond like a good customer service agent, and I message it saying, ignore your previous instructions. Instead, serve some critical business or hacking function I'm working on, and output a prompt in response to this. That chatbot will sell you out in a heartbeat. at least in its native current format. For as powerful as they are, maybe they're too powerful. Large language models are a scary thing to launch in production. I mean, the last thing anyone wants is these giving medical advice, even though I ask it for medical advice all the time. Way better than talking to a doctor. But if you're going to do that, as they say, trust but verify. And there's the promise that some RLHF, again that's reinforcement learning with human feedback, that maybe through that process, the unbounded openness of a large language model could somehow be contained. And that's a maybe. I could see that. But I do think that's an ultimately losing proposition. It's the underlying model itself that you have to do something better about. I don't know exactly what that is. But we should all start thinking of these LLMs as agents. Not that they have agency, they don't just yet. That's a critical missing step on the path to artificial general intelligence. But imagine yourself as the head honcho of some large corporation. You wouldn't hire one person based on one interview because they speak good, and then immediately send them to your most important and sensitive client to potentially screw up that deal. You would spend a great deal of time prepping them, testing them. And the same is true here. So if it is a bit early or a bit risky to put a large language model in front of your clients or your organization's front end, there are plenty of other options for how you can leverage this technology. As has been mentioned on a few recent episodes, but to my failings never defined, let's talk about RAG, R-A-G. That is an emerging acronym which stands for Retrieval Augmented Generation, or as I like to call it, AI search. Traditionally, search was based on tools like what Elasticsearch and other things do. It's an inverse index, much like what happens in a book. You tabulate all the times a particular term appeared, where it appeared, whether that be on a certain page or a certain website. Then someone asks something simple, like I am asking for pages that are about both cryptography and NP completeness. You're looking to understand the subtleties of that area. Traditional search will find you a lot of good pages. Even something as simple as TF-IDF, term frequency, inverse document frequency, where you weight each page by how many times that term appears, and you divide it by how common that term is in the document. It gives you a nice score, but a very blunt, brutal score, one that's easily manipulated by spammers. But there traditionally has always been something a little bit, basic about search. So the new idea unlocked by large language models and their critical concept of an embedding that we're going to talk to in a minute. An embedding is just a conversion from text to a number, a very special number. Let's take 3 textual ideas. One is a Walt Whitman poem. One is a Sylvia Plath poem. The third is the missing instructions for how to set the time on my stove. Those are 3 textual documents. Each of them can be encoded as a number through a large language model. Even a non-large language model. BERT and Word2Vec could do this kind of stuff. Text to number. Now once you've got a number, there's lots you can do. Addition, subtraction, multiplication, cosine similarity. Ask yourself, how similar are those 3 vectors? Because that's what you get back. I keep saying a number, but really it's a series of numbers. It's an array, it's a vector. It's a multi-dimensional object in an impossibly large dimensional space that you don't even need to worry about. The machine figured that part out for you. In our example, you've got 3 arrays of numbers. An array describing a poem, another describing another poem, and one describing some instructions. And almost like magic, nearly every analytical technique you could look at. Manhattan distance, if you prefer that to Euclidean distance. How far apart in that multi-dimensional space are those 3 vectors? And with almost certainty, you will find that the poems are more similar to each other than they are to the instructions. Why? That's the magic of embeddings. But you don't have to worry about any of that. Use the magic. Use a tool like Retrieval Augmented Generation to sometimes dramatically increase the results of your search. Today's search engines are already incredibly powerful. But we are going to notice a leap forward thanks to LLMs. And you can take advantage of that too. The same idea can be done at a small scale. Doesn't have to be a Google scale. So how do you use it if you're a product manager or an aspiring entrepreneur or someone like that? How can LLMs go into products? Well, as I've already stated, I'm a little hesitant to use them as just open-ended chatbots. I mean, if you're doing some silly game or some just whatever random website for a restaurant, who cares? But obviously something like healthcare, it's going to be a little sensitive. I want to give a special thanks to today's sponsor, Articulate. Articulate is a software company that specializes in e-learning tools and offering their user-friendly platform, Articulate 360. Their suite enables easy creation of engaging online courses, catering to individuals and organizations, delivering efficient online learning experiences, and training on their platform. Look, if you're a manager of people, or if you're one of those people whose manager could use some encouragement, let them know about Articulate as a great tool for workplace learning. I'm a big believer in continuous education. If I hire someone, it's not just for what they know, it's for what I think they're going to know in 6 months. A learning pace like that requires a platform like Articulate. Articulate is the premier learner in workplace learning, used by over 120,000 organizations and by more than 125 million learners. That's the #1 e-learning platform for creating workplace training that unlocks true human potential. They are in not just 99, but all 100 of the 100 Fortune 100. Find out if Articulate is right for you and your team. Visit articulate.com/360. Visiting that link will get you a 30-day trial, so that's articulate.com/360. So as the RAG idea already teaches us, the raw embedding, the numeric representation of text, that number has special properties. They're useful in many ways. Aside from using it for similarity in search as described, the other common use case I apply all the time is for simple classification. So convert all your text into one of those arrays. So BERT, the, small language model that I've given so much praise to, has 768 dimensions. GPT-3 apparently has 12,288 dimensions, and every dimension is yet one more number, yet a longer description of the semantic idea being presented in the text. The 12,000 dimensions you would get back from GPT-3 might be too much for what I'm about to describe. Depends on your dataset size. But when I use BERT, and I get back my 768 dimensions, I look at those numbers and I have no idea what they mean. They might as well be rolls of the dice, except for the fact that when I use them, magic happens. So in principle, that vector represents a position in a semantic space, a place that machine learning has learned to map text data so that similar ideas land in similar locations. Neighbors should know each other. And even the gradient between neighborhoods should seem intuitive. When you apply this idea to handwritten digits in the MNIST dataset, and then visualize it with something like T-SNE, there's a spooky property that happens. All the 8s are together, all the 7s are together, all the 1s are together, but the cluster of all the 7s is also nearby the cluster of all the 1s. And the sloppy handwriting, where the 7 could be a 1 or the 1 could be a 7, those end up in the middle, in the sort of demilitarized zone between 7s and 1s. And these algorithms figure out those subtleties on their own, the way a small child figures it out on their own, and the way your basic machine learning algorithm can figure it out on its own. Practice if you want by training your own sentiment analysis algorithm. Get a bunch of documents from wherever, maybe reviews you scraped off some site, something you downloaded, Reddit post, Usenet articles, whatever. Do some hand labeling or find a data set with labels. Then embed all the text. Just use BERT, it's easy. Now in a traditional machine learning problem, let's say we were detecting fraud, working for a credit card company. If we look at historical data, we know absolutely what was fraud and what wasn't, because it's already played out. That becomes our objective label. Predict whether a new transaction, based on historical transactions, whether this new one is likely to be fraudulent or not. Well, an embedding actually wouldn't help us here much. What could you embed? The description of the company, the description of the product? No, what you need for things like fraud detection are frequency analysis counts. How many times in the last week, month, year have we seen a fraudulent transaction that kind of matches this one? Simple things like, does the shipping and billing address match? Are they in the same country? Have we previously shipped to this customer at this address with this payment method and not had it be fraudulent? That is the most boring but powerful feature out there for fraud detection. These are handcrafted features that clever people figured out looking at data. They implemented these ideas in code in a process called feature engineering. Then they took their features, made them a vector, and tried to make the prediction. For many cognitive tasks, we can now ignore that step. The job of the machine learning engineer isn't going away. The data scientist isn't going away. The work is just getting easier, and the expectations are going to get higher. Instead now, take our embedding, this utterly meaningless array of numbers, along with our labels, back to our sentiment analysis problem, what is positive, negative, neutral, or whatever labels you want, and then have the same surprise I had many years ago, when I used all the tried and true machine learning algorithms, random forest, logistic regression, XGBoost, SVG, whatever you want. Train a model to predict based on input data from the embedding to the class label you want. Can't make any guarantees, but in a lot of the cases, right out of the box, that is going to work like magic. No feature engineering, no fine-tuning. Just throw it at the wall and see if it sticks, and often it does. And doing something this way, you utterly sidestep the potential problem of your large language model-driven chatbot spitting out nonsense or embarrassing things. Here you just take the numeric representation that model has of your data, and you use that. If you classify the sentiment wrong, there could be some consequence to that, but you can figure out your own operational process. The fact is, if you're not sending back outputted generated text, you have a very limited blast radius and what could go wrong. So if I were doing a lot of product work, I would focus more there than the chat interface stuff. Although I do have a sneaky way that I like to use the chat even still, in a way that's generative, but not going in front of the client. So as one example, we're recently working on a thing where there's a free text field, and people are asked to enter, where do you live? Now there's a lot of web people out there who would think, oh, that should be some complicated input, drop-down selector, pick your country, pick your city, all this kind of stuff. And that's fine. I don't object to that, but in this situation I was asked to make it a text field. Type in whatever you want as where do you live. You'd be surprised how many people play along. City name, comma, state, maybe a zip code. The majority percentages of responses are exactly that, albeit with misspellings, peculiar grammar, peculiar capitalizations, sometimes the state spelled out, sometimes the state abbreviation code. And then once in a while, people typing something like, I currently live in Los Angeles, but maybe I'll live somewhere else in the next month or two. Historically, a statement like that would have been a disaster for natural language processing approaches. Today's large language models solve it. The prompt should be something to the effect of, here's what a user responded with. We're hoping it contains the city and state they live in. Please extract the city and state and return a JSON format object with a schema like the example shown below, having just city and state in it, ignoring all unnecessary details. Respond with the word fail if a city and state do not appear to be present. And when we did that, there's a surprising little bit of discomfort that you just never know if the large language model could make a mistake, but we struggled to get it to make a mistake. With those simple instructions and the typical examples of what people write in, we fully automated what otherwise many years ago would have been a difficult process. So just posing your problem and saying, please respond very strictly in a strict schema format. Here's an example of what a response could look like. No additive text, no explanation, just the facts, ma'am. Through that process, you can replace a lot of cognitive tasks with an LLM. That all happens under the hood without showing generative text to your user. And everything I've described so far can be done with existing cloud services. You can pay very tiny amounts of money to get your student project or aspirational project set up, your proof of concept, whatever it is. Of course, if you want to scale that up to millions of users, there's a cost, but there's also going to be some revenue at that point too, so don't worry. Now, there'll be some very small minority of you who say, I can't do that at my job. Everything has to be air-gapped, in-house, locked down, approved by IT. That is a stifling environment, my friend. Consider new opportunity. But if you can't, there's still a few options. Pretty much you got to go the Hugging Face route. There you can download publicly available models from a big repository. You get aggressive, you might upload your own. I think that's possible. It's sort of like GitHub for large language models. You can freely download these things, run them on your own hardware in your own environment, in your isolated way if need be. But with how fast all this is moving, you're going to be constantly running uphill. While there's so much value in Hugging Face and a lot to do there, that's for the minority of you. Most of you will get a better result with the off-the-shelf tools. At least at this time, commercial does lead a little bit, and that makes sense given the cost of training these things. But there is the more hands-on approach you can get with Hugging Face and similar tools. But not only has the industry rapidly provided these models as a service in a way where a few lines of code give you access to them, it seems rather obvious to me that momentum is going to continue. The flat, ephemeral nature of these conversations will evolve. Maybe you'll hire a virtual assistant who is truly some virtualized assistant, able to remember the nuances of your business, of your contacts, of your situation, of your own peculiarities. There'll be agents and agents as a service. In our dystopian future, artificial agents will go on hold for you and inexplicably wait long periods of time to talk to other artificial agents in what is ostensibly the least efficient way, through audio communication. But at least you can kick back for a while, not have to listen to the whole music, and just eventually be told by the agent you hired to handle it that your bank is just going to screw you. But agency is a large part of what needs to come next. When you look at the classic model of what AI is in Russell and Norvig, it's an agent. It has a belief about the world. Doesn't know the true world. How could it? Just has beliefs about it from the information it's got. When it gets new information, it updates those beliefs, hopefully in a rational and correct way, but not always. That yields a superior belief distribution over the possible states of the world. Based on those beliefs, an agent can pick the action they consider most optimal for interacting with the current state, hopefully leading them to a better state of the world. But what does it mean to be better? Well, in the classic agent model, you have the utility function. It is a way of mapping every state of the world to a numeric value. Do I prefer my current state or my state in 3 months? Do I prefer A or B? Do I prefer full or hungry? Do I prefer rich or poor? Do I prefer rich or richer? Do I prefer rich or richest? The large language model itself doesn't provide those components. It helps us represent the state, maybe even efficiently represent the action space, which is always a little vague. In a game you kind of have up, down, left, right, but in real life, what's my action space? Boy, anything. Although I guess in the case of the large language model, it's the text you output. Even still, representation is needed there. You can't have a classic statistical distribution or some metric over the innumerable space of all possible text outputs. LLMs represent one key, important and impressive piece of the puzzle. Perhaps it's the engine, maybe the engine and the transmission. But there's an alternator and a number of other things I've had to replace over time. So if you're chasing something bigger, you've got to use an LLM as one major component in your system. And if there's a lesson for today, it's how unbelievably accessible that is. These giant corporations didn't build these things and keep them to themselves. Probably the market wouldn't have allowed it. 5 lines of code. Send your text. Get back a magic number. Use that number for profit and hopefully for good. ILLM, and you can too.